All right. So this says that you use your camera to take a close-up picture of a giraffe at the zoo. The height of the picture is 3 inches, and the width of the picture is 4 inches. Okay. So you can see here, the height is 3. Just a second. All right. You can see the height is 3 and the width is 4. So we're going to be talking about the constant of proportionality, okay? The constant of proportionality, otherwise known as the COP. Big C, little o, big P. Now, if you look at this coordinate graph, how can we use the graph and coordinate pairs to find the dimension of a picture that is proportional to the original? So here's what I want you to see. If I take this picture of the giraffe and I take that corner, as long as this corner stays on that line, every place on that line, as long as that corner is on the line, that picture will be proportional to the original. Say, for example, what if I made the height of the picture 6, then the height would be 6, and the width would be 8, and the picture would not be distorted in any way. Okay. If I made it even smaller, what if I made it smaller? If I wanted the width to be 2, then the height would have to be 1.5. So we've got, if we take if we divide, how can you use the graph coordinates to help us? So we're not going to worry about answering this question A necessarily, but we are discussing it, okay? So if we want to keep that picture the same, we have to make sure that that corner always is going out the same as it's going up, so that when we look at the ratio of height to width, it will always be the same when we divide. Okay. Now let's see, 3 and then 6, 1.5. Well, I doubled it. I cut it in half. If I multiplied by 3, then if I could make it 9 inches tall, but then I would have to come down here and I would need, 9 inches tall. It would have to be 12 inches wide in order to stay on that line. So the dimensions of at least 3 pictures that are proportional to the original picture for question B, well, we would have 1.5 by 2, 6 by 8, 9 by 12. Those would be 3 pictures that would have the same proportion as the original, where if you take this, and this is what we're looking at, the constant of proportionality. What is a constant of proportionality? So let's think about that for just a moment, okay? What is the constant of proportionality? And what we're talking about with the constant of proportionality is you have to look at the basically the quotient or the ratio between in this case, the height and the width of the 2 pictures. Okay. It's the numerical portion of the unit rate. Now, we talked about the unit rate before. Matter of fact, let me just take a look at this here. I'm going to see if I can make this happen. This should be interesting, rather than typing it all out. Yeah, there we go. So the constant of proportionality is the numerical portion of the unit rate. So as it is moving up, it is also moving over by the same rate. That's the what do you call it? The rate of change. It's the constant of proportionality. It's if this was if we were talking about the equation of a line, it would be the slope. Okay, but in this case, it is the quotient of the y value and the corresponding x value. So the constant of proportionality. Whoops, hold on. Constant of proportionality would be. Oh, come on! What is the deal here? Draw. Why won't it let me draw? It doesn't like me. Okay. All right. So the constant proportionality, in other words, the COP is the y value on a graph divided by the corresponding x value, like you see here. And so in this case, we had the original was 3 divided by 4, which is the same thing as when you divide 3 by 4, you get 0.75, okay, or 3/4, whatever. But you get the same thing if you divide 1.5 by 2. It's still going to give you 0.75. And also, if you take 6 divided by 8, that'll give you 0.75. If you divide 9 by 12, you get 0.75. It's called the constant of proportionality because it is always the same. It's constant, okay? So there's a specific variable that we use to represent the constant of proportionality. So y divided by x will always give you the k, yk. I have no idea, but that's a universally recognized symbol for the constant of proportionality. Okay. Right there. So in the giraffe photo situation, the height equals the constant of proportionality 3/4 times the width. Now, in this case, so you've got this equation right there. The height is equal to 3/4 times the width. And of course, 3/4, that's that 0.75. So the height of the photo is what they're saying is always 3/4 or 0.75 times the width. So the camera shop, moving on here, the camera shop makes pictures into posters with a width of 12 inches. So what will the height of the poster be? Well, again, like they said, the height is equal to, and that's 3/4 times the width. Well, so we know what the width is. It's 12. So the height is going to equal 3/4 times 12. Now, if we want to simplify that, we multiply 3 times 12 is 36. 4 times 1 is 4. And 36 divided by 4 is 9. And so the answer to our question is, what will the height of the poster be? It will be 9 inches high if the poster is 12 inches wide. Because 3/4 is our constant. We multiply that by the width to get the height. Okay. So now this particular photograph looks like the same photograph to me, is 4 inches wide, but it represents 16 feet in actual distance. So if 4 inches is the same thing as it represents the 16 feet, the height of the giraffe is 3 inches. So what equation could we use to find the actual height of the giraffe? So remember, we're looking for the height of the giraffe. And again, remember, the height is equal to 3/4 times the width. Okay. Now, what is the width in the particular situation that they gave us? Well, it's 16 feet. So the height would be equal to 3/4 times the width of this was represented by 16, and that 16 is in feet. Now, there was another way that you could have done this. For example, maybe you know that 16 feet is the same thing as 192 inches. So you could have also said that the height is equal to 3/4 multiplied by 192 inches if you wanted it to be registered or measured in inches. Either way, it's fine. Now, in this, now we've been talking about unit rates. And remember, with every ratio, there are two unit rates, right? There are two unit rates. So remember, in this case, we're talking about height to width, right? And our height to width was 3 divided by 4. And remember, if we wanted to make this a unit rate, then that would be for every 1 inch of width, we would have 0.75 feet or whatever units in height. So 1 unit in width would be 0.75 units in height. But that's just one unit rate. We still have to talk about the other unit rate where we turn it upside down. We talk about the width compared to the height. And that, in this case, would be 4/3. But if we turn that into 1 there, well, 3 divided by 3 is 1. 4 divided by 3 is 1 1/3. So we would have, for every 1 unit in height, we would have 1 1/3 or 4/3 or units in width. So 2 unit rates for every ratio. Remember, every ratio has 2 unit rates. And it looks like I am out of time. So let me stop my recording here.